Okay, so make sure that you really take a look back at those Tarzan examples and understand why we set it up that way. Those were nice and easy where we had one type of energy on each side of the equation. Now, here, let's look carefully at this problem. We have a tightrope walker that is suspended in the air at 3,150 meters above the ground. So for right now, I know for sure that she is some height above the ground. She has gravitational potential energy. Okay, so let's keep reading and see what else is going on. It says, now suppose a coin falls from their pocket during the walk. So we're not really focused on the tightrope walker. We're focused on the coin. So the coin is also some distance above the ground. So I know the coin has potential energy. However, if the coin was just chilling, sitting in her pocket, then it doesn't have a velocity to start with. Okay, so on my before side, all I should have is potential energy. The question is, how high above the ground is a coin when its speed is 60 meters per second? So there's a hint that on my after side, I definitely have a speed, so I definitely have kinetic energy. And they're not interested in when the coin hits the ground. They want to know how high it will still be, which means it's still going to have potential energy. So let's take a look at our COE expression. I have potential energy before because the coin is above the ground. I have kinetic energy after because it started to pick up speed as it fell. And I also have potential energy after because I have not been given any indication that it's going to hit the ground. So again, make sure you really understand why this is the correct expression, because from here it is just algebra. Okay, so if we go ahead and write out all of our equations, every time you see a PE, that equation is always mgh. Wherever there's the K, you see your 1/2 mv squared. And still, mass is in all three of my expressions, so therefore mass will cancel, which is why we were not given the mass information of the coin. Okay, so when we cancel it out, we're just left with this. Okay, be careful. You cannot cancel out anything else. Even though it's tempting to cross out those G's, all three terms do not have a G in it. While it's tempting to cancel out those H's, all three terms do not have an H, and those H's represents different values. Okay, so when we plug everything in, for the before information, our initial height was at 3,150. So we have that in multiplied by 9.8. Okay, then on the other side, we have our 1/2, velocity is 60 squared, plus our 9.8 H. Algebra wise, we need to multiply these two numbers together first, see what we got. Do your 60 squared times 1/2, see what you got. Okay, and then we start to make algebra mistakes here. Remember, these two terms are still being added together, so we need to subtract these terms first before we go back and divide by 9.8. So if you follow all of those algebra rules, you should get a height of 2,966.3 meters. Okay, if you did not get that answer, you want to make sure that you ask questions in class next time to get support on the algebra. If you still don't understand why the equation was set up this way, then you need to come in and you need to ask questions to make sure you understand the physics concept behind it. Okay, so make sure you bring in all your questions, rework these three examples on your own since you have the solutions to make sure that you fully understand.